Assalamualaikum and hi to everyone. Thank you for watching this video. In this video, we will discuss about the data and signal in set 3. So in data communication, basically we only have two types of signal in data, which are one is the analog and another one is the digital signal or digital data. So throughout this topic, you will learn about the analog signal, the digital signal, the broadband and passband transmission, and then you also will learn about the transmission impairment. What are the terms that we use in order to call the impairment during the transmission part, and then the data rate limit. So basically, when we talk about data rate, it reflects to the digital signal. In digital signal, we will talk and discuss about the data rate, and then we come for the network performance. So in order a signal or data to be transmitted, the data must be transformed into the electromagnetic signal. Only if the data being transformed into the electromagnetic signal, then we can transmit the data. So data and signal can be analog and digital. So analog, it will take the continuous data. What is the continuous data? Example, we have the temperature. So 37.5, 37.6, 37.7, that is the continuous data. For digital data, it has a discrete value. Okay, it has a discrete state and it takes the discrete value. Okay, example of discrete value, we have 1, 2, 3. In digital, we only learn about the 0 and 1. So first we go for analog and digital signal. Analog signal can have infinite number of value in the range because it's continuous data, and digital signal can have only a limited numbers of value, either 0 or 1. Okay, this one is the comparison between the analog signal and the digital signal. So you can see, based on the figure A, analog signal, we have the continuous data. And based on this figure graph, okay, for digital signal, we have discrete value of data, either 1, 0 or something. So this is discrete value. At certain point, there is no data involved. Okay, there is no data at here part. So these are the difference between analog and signal. In data communication, we always commonly that we use the periodic analog signal and non-periodic digital signal. So what is the periodic signal? Okay. Periodic signal consists of continuous repetitive pattern within a time frame that we call as period. So within a period, there is a continuous of repetitive pattern. We can see the pattern when we look at the graph later on. So the completion of one full pattern, we call it as a cycle. Cycle of pattern, we call as cycle. So the amount time is measured in seconds, and it required to complete one full cycle is called period. So one period, one full cycle. For non-periodic signal, there is no repetitive pattern. So when you look at the graph, you can't find any pattern that being repeated again, okay, again and again. In both periodic and non-periodic can be decomposed into infinity number of periodic signal. Okay. So let's see. We look at the periodic signal. So this is example of the periodic signal for analog, and this one for digital. So based on this signal, you can find the pattern, the repetitive pattern. So this is one cycle, and one cycle we call as a period. So this one is one cycle in one period, another cycle, and another cycle. Okay, this one for analog, this one for digital. Even there is digital and analog, but we still can identify the pattern, the repeated pattern. This is how the non-periodic or a periodic signal look alike. Okay, you can find the pattern. There is no repetitive pattern. Okay. Periodic signal can be classified as a simple or composite. Means when we talk about the periodic signal, it can be a simple signal or a sine wave, and it also can be a composite signal. Composite signal means that it's a combination of multiple sine wave in one signal. Okay, so this is the sine wave. It look like this one for analog. And for sine wave, there are characteristics that you should know. The first one, we have the amplitude. The second one, we have the frequency. And the third one, we have the phase. So what you should know here, what is the amplitude, what is the frequency, and what is the phase. How to interpret, how to describe, and how to calculate. Okay, amplitude is referred to any value at any point of wave on a time domain plot graph. So basically, we will represent the signal sign or the sine wave in the time domain plot graph, and based on the time domain plot graph, you can identify the amplitude value. Amplitude is the any value that any point on the wave, and it is measured by volt. Okay, this graph is the time domain graph. Okay, this is time, so this one is the time domain plot graph. So this is a sine wave. So amplitude is a value at any point on the sine wave, and the maximum amplitude we call as the peak amplitude. Okay, next part, what is the frequency? So frequency based on the formula 1/t. T is referred to the period. One full cycle is one period. So frequency and period are the inverse of each other. So based on this formula, you can identify the frequency, and you also can identify the period. F equal to 1/t and T equal to 1/f. Okay, frequency is the rate of change with respect time. So basically, we will use time in seconds. So change in a short span of time means high frequency, and change over a long span of time means low frequency. If a signal does not change at all, so we call as a zero frequency signal. And if a signal changes instantaneously, its frequency is infinity. Okay, period in P, the amount of time in second. As I mentioned before, we measure in seconds. Needs to complete a cycle. How many seconds that the sine wave need to complete a cycle? And frequency is the number of cycle in a second, and the frequency is measured in hertz. So P equal to 1/f, F equal to 1/p. Okay, like the before, F 1/t, same thing. Okay, this is an example based on this time domain plot with one sine wave. So this signal is in 1 second. Okay, we will calculate in 1 second. So in 1 second, we're able to create how many cycle? 1, 2, 3, 4, 5, and 6. So 6 cycle in 1 second. That means the frequency is 6 hertz, and the period is 1/6 per second. Okay, please bear in mind a frequency, a complete cycle in 1 second. Okay, this figure shows the example of two signal with the same phase and frequency. Frequency is similar. 1, 2, 3. So 1, 2, 3. So similar. At this time, it has 3 cycle of complete cycle. 3 cycle of complete pattern. Okay. But the difference is at the amplitude. This one and this one. So basically, based on this signal, you should know what is the amplitude, how to find the amplitude, how to find the frequency, how to calculate the period. Another example. This example shows two signals, okay, two signal with the same amplitude. The amplitude is similar and the phase also similar, starting at 0 point but different frequency. Okay, you can look at this sine wave, have different frequency. This one we have 12 a cycle, complete cycle. At this part you only have 6 complete cycle, so the difference is at the frequency. So this table show you on how to do conversion unit of the period and frequency. So basically, in commonly we use frequency in second, so you should know how to convert in millisecond, microsecond, nanosecond and picosecond. And frequency, the unit of frequency is in hertz, so you should know how to convert kilohertz, megahertz, gigahertz and terahertz. Okay, look at this example. The power we use at home has a frequency of 60 Hz. So frequency equal to 60 Hz. The period of this sine wave can be determined as based on the formula T equal to 1 over F. As I mentioned at the previous slide, frequency and period is inverse to each other. So T equal to 1 over F, 1 over 60 Hz. So this one, the value you will get in second. So if you want to get the value in the millisecond, you need to time with 10 power of 3. So at the end you will get in millisecond. But this one is the commonly used in second. Okay, the next example, express a period of 100 millisecond in microsecond. You have millisecond, need to change into the microsecond. So based on the table here, based on this table, milli and macro, 1 millisecond is equal to 10 power of negative 3 second, and 1 second is equal to 10 power of 6 microsecond. So we make this following substitution. First, we need to convert first the millisecond into the second in order to identify the second, and then we convert into the microsecond. So 100 millisecond equal to 100 times 10 power of negative 3 second. After you get the second, you need to time with 10 power of 6 microsecond in order to get the microsecond value. So 10 power of 2 times 10 power of negative 3 times 10 power of 6 equal to 10 power of 5 microsecond. Okay, this one is mathematic part. So times, we just add the value 2 plus negative 3 plus 6. Okay, so at the end you will get 10 power of 5. Another example, the period of signal is 100 millisecond. What is the frequency in kilohertz? So you need to identify frequency in kilohertz. Okay, we have the signal, the period of signal is 100 millisecond. So we need to convert first the 100 millisecond into the second, and then calculate the frequency from the period. 1 Hz equal to 10 power of negative 3 kilohertz based on the table that I already showed you before. So based on this formula, 1 over 10 power of 1, how to get 1 over negative 10 power of 1 over 10 power negative 1. Okay, 100 millisecond is equal to 100 times 10 power of negative 3 second. So this one we convert first into the second, identify the hertz, so we get this hertz, okay, equal to 10 hertz times 10 times 10 power of negative 3 kilohertz. So at the end you will get data in kilohertz. So until this part, you should know how to calculate and do the conversion. So next video we'll discuss on the pace.